I welcome you to this class of econometric methods. Myself, Dr. Muhammad Imdadul Haq, an associate professor at the Department of Economics, Aligarh Muslim University. Today, we will be doing our discussions on analysis of variance. We have seen in our previous class analysis of variance purely in the concept of statistical orientation. Now, here what we are doing, we are trying to give a feel that these two things, like is analysis of variance and regression, they are related in many ways and also they are different in many ways. And also in our subsequent classes, we will see that how the method of analysis of variance can be used in things like understanding the contribution of an additional variable, seeing difference between two variables, and also when the sample size is being increased, what happens to the stability of the coefficients estimated. So what we are doing here, we are showing a variable x1, and it is like it forms one category and it has the related values of y. Similarly, in the second category, as highlighted with the green color, we have different values of y. And there is another category, the third and the last one, which is associated with different values. So what basically we are doing over here is we are trying to categorize y, the variable y, with respect to an identifier like x. Now, Anova identifies and divides the total variation of a variable related to different factor. This may be factor 1, this you can say it factor 2, and this can be factor 3. It deals with the values of y and estimates their variation. We will see the variation between this is how it is similar or different to the variation of this, and is similar or different with the variance of the last set. And here see, our x is just used for categorizing y into different groups. So that is what we are doing over here. So what Anova does, it estimates and compares two variances and tests whether the difference between these two is because of the sample that has been selected, or it is really that same difference is there in the population from which these samples have been extracted. Here the comparison between the variances of two or more samples, the comparison of the variances between two or more samples is being done through F test. F gets its name from Fisher. The null hypothesis is that there is no significant difference between the two variances. And if the difference between the two variances is big, the F ratio value the calculated value of F ratio, it will also be big, and there is a greater chance that we will be rejecting the null hypothesis. So we have taken, we are just working on it. We are showing it separately as y1, y2 and y3. We have divided into three groups. For the first group of y1, we calculate the mean of it. This is the mean of it, that is equal to 100. Then here we do y1 minus y bar, that is we minus 80 minus 100 minus 20, 90 minus 100 minus 10, 100 minus 100, 0, and likewise. Then we do y minus y bar, the whole square of it. Finally, we do the summation of this. So this is equal to summation y1 minus y bar whole square, that is equal to 100. The same thing we repeat for y2. We have y2, we have the mean of y2, that is 150. Then we do y2 minus y, this is y1 bar, y1 bar. This is 150, 130 minus 150 is equal to minus 20. Then 140 minus 150 is equal to minus 10, and likewise and then we do y2 minus y bar, the whole square of it. Finally, we add all and we get summation. This summation is y2 minus y bar, y2 bar whole square. This is equal to 100. The same process is repeated for y3. We take the values of y3, we get the mean of y3, that is equal to 200. Then we do this is y3, then we do y3 minus y3 bar. We get 180 minus 200, that is equal to minus 20, and likewise. And finally, we do y3 minus y3 bar, the whole square of it. And this is summation y3 minus y bar whole square, and the summation of this is equal to 1000. So we have taken a simple series. That is the reason here also it is 1000, 1000 and 1000. This is just because of the data which has been taken, and it will not necessarily be the same, that these things will be the same. It's not at all necessary. Then in one case we add all of these values together, means the values of y1 and the values of y2 and values of y3, we take all of them together, and this is my y. Then we calculate the mean of it, that is y bar. So we calculate y minus y bar is equal to 150. So 80 minus 150 minus 70, 90 minus 150, 90 minus 150, that is equal to minus 60, and likewise. And then we do y minus y bar, the square of it. So for minus 70 we get 4900, for minus 60 we get 3600, and likewise. Finally, we add all of them, and this is summation y minus y bar whole square, and this we get as 28,000. Now, so the variance, so we are going to estimate the variation between the sample means. Now, the null hypothesis is mu1 is equal to mu2 is equal to mu3. Why we are referring to mu? Because hypothesis is always about the population. Now, y1 is the mean of y1 bar is the mean of y1, y2 bar is the mean of y2, and y3 bar is the mean of y3. And what we mean, they do not vary amongst themselves and also do not vary from the grand mean as such we had, where we had taken all the values together, that is y bar, that is mean of all the three samples. Then we use the formula for variance, that is basically is written over here, nj, summation nj bracket yj minus y bar whole square divided by k minus 1. Now here the variance is estimated from the difference of the individual sample mean and the common population mean. The population variance is, that is sigma hat square, it will be large if H naught is not true, that is the null hypothesis is not true. As here the variance which we are computing is by using y minus y bar, the whole square of it. Now, we do not know the population variance. So, when we do not know the population variance, what we are going to do? We are going to use the sample variance. And as such, see, the sample variance are not impacted by the differences in sample mean. Although the mean may vary significantly, that is the population from where the samples are taken, the mean may be different, but they may have the same variance. So this is what is to be emphasized and understood properly. The population from which these samples are taken may have the same variance, although there may be difference between the mean of these series. So to calculate this, we denote it by sigma double hat square. So we have n1, that n1 is the number of items in sample 1, and the sample variance, plus n2, this will be this will be n2 plus the sample variance. Similarly, we will take n3 sample variance square, and this will continue up till the number of items you have taken. If there are 4, then you will continue up till 4. So k is equal to 4, you will have 4 terms, and here we have k is equal to 2, we will have 2 terms, and divided by, in the denominator we are taking care of the degrees of freedom. So in the denominator we are taking care of the degrees of freedom, that is n1 plus n2 plus up till the n's that have been incorporated, that is nk, minus k, the number of variables. Now this n1s1, this n1s1, this is n1s1 square, this is equal to n1, and for how we get this s1, y, that is the y1, the mean of the first variable minus the mean of the where we have taken all the 3 together, that is the grand mean as such. So mean of the first variable minus the mean of all the variables, that is the grand mean, divided by n. So n is cancelled, so we are left with this. So finally we define sigma double hat square as a summation of, we do it for the first series, then we do it for the second series, and then we do it for the third series, divided by n minus k. So what we have basically assumed, that according to the null hypothesis which we formulate, we assume that these samples x, that is y1 and y2 and y3, these samples are drawn from a normal population. Since Anova is a parametric test, so this we need to check for the normality of the data also before you do this Anova. Now, although the mean for the first series mu1, the mean for the second series mu2, and mean for the third series may be different, the standard deviation, because of this normality, the standard deviation would be the same. And in Anova, we test for any significant difference between the mean of the 3 different populations. That is why if you have only 2 populations, then we need not go for Anova. We simply go for t-test. We compare these 2 series by using t-test, but when there are more than 2, then we have to go for Anova. So the null hypothesis over here is mu1 is equal to mu2 is equal to mu3, and the alternate is at least one of the means would be different. That is the alternative of it. If your null hypothesis is true, it means the mean of the first series is equal to the mean of the second series is equal to the mean of the third series. That is, the mean of y1 is equal to y2 is equal to y3. And the within sample variance we calculated by nj yj bar minus the y bar for the whole mean, the whole square of it, divided by k minus 1, and it will be large if your null hypothesis is rejected, then it will be very large. So when the means are not same, that is the variance is larger, then we have a large f value. Now the formula for f statistics is between the mean variation divided by within the sample variation. Between the mean variation formula is this, that is summation from when j is equal to 1 extending up till k, nj multiplied by, in bracket, y bar j minus y bar divided by k minus 1. This is the between the mean variation, and the within the sample variation is, we do the summation of the summation and of yji minus y bar, y1 bar whole square divided by n minus k. So we have done the calculation just before. So what is basically over here, if your calculated value, f asterisk is the calculated value which we get from here. If this calculated value is greater than the table value, this is the table value. If this calculated value is falling over here, then H naught is rejected. So it means that the population from where the samples are taken are different. And if it falls, if it is less than, if it, suppose my statistics fall over here, in this case H naught is accepted, meaning thereby the population from where the samples are taken are similar. Now another concept which we need over here is to understand is that total variation is equal to between variation plus within variation. This is the total variation between variation. This is between, and this one is within. Now we will see how we get this. We can also derive and show it. Let's take a case. Y1j minus y bar. We simply write it is equal to y1j minus y bar. Now we do an algebraic manipulation, that is, to the right hand side we add and minus by a term yj bar minus yj bar. So we add yj bar and we also minus yj bar, meaning that the impact would be the same. So that has been added over here to the right hand side of the equation. Then we rearrange all of this. So we take this y1j minus yj bar and this minus y bar, this will take, the next one is yj bar minus y bar. So this is how we rearrange. So we get bracket open y1j minus yj bar plus bracket closed plus bracket open yj bar minus y bar. Now we square both the sides. So here also to the left hand side of the equation we add a square, to the right hand side we add we also square it. So this you can write it in the formula for a plus b whole square. So we have a square plus b square plus 2ab. Now so finally we do the summation. We have already done the square, and when we do the summation we get this value over here, and we do the summation of the first value, the summation of the second term, and the summation of the third term. So the same thing which we have got in our previous slide is shown over here. Now see, this last term will become 0. What we are having this term, and in the bracket it is y1j minus yj bar minus y bar. This can, if we can write, what is this? y1j minus yj bar is equal to 0. This is 0. This entire term, it becomes 0. Because if this is coming from there, this is x, and when we do x minus x bar, when we do the summation of this x minus x bar, the summation will be 0. So when it is 0, so we are left with this term. This is nothing but my total variation. This term, this is nothing but my within variation, and the last term, this is nothing but my between variation. So we can say, we can divide our total variation into two things, that is within variation and between variation. We normally, this type of table is you will get in softwares also, in Excel sheet also, you will get a table like this. We are just explaining you the table, but at the moment, let us, what are the things which are given over here? y1 summation of all of this, then divided by 5, so we get this, and the calculation of the variance of this series, we have got 100. These calculations we have done earlier, we are just writing it in this place. Similarly for y2, the summation is this, the mean of the y2 series is this, the variance is this. For y3, the summation is this, the mean is 200, the variance is also 200. And finally, for the last, the entire y series, for this y series, the total is this, the mean is equal to this, and uh, this we keep it off. And if we do this variance, we have, when we calculate the variance of the entire series, we get 2000, sorry, we get 28,000. So we are just reflecting upon the formula for between variance. So what we have done, when we open up this when we open up this formula n1 there are 5 n, so we write 5 over here. Then we have y1 bar, y1 bar 100, we write 100, minus y bar is for the all the values when they have been taken together, then we square it. The next time n2, again this is also 5. Now with the 50, this 50, this 50, and this 150 is again this 150 for the grand, all the values taken together. Next time for the third term also, n is equal to 5, 200, we get the 200, the mean of the series, and then divided minus this 150, that is the mean of the entire series, then we square. So upon working on opening the brackets and working upon this middle term, it becomes 0. So this becomes 12,500. This is also 12,500 divided by 2. So the final answer over here is 12,500. This is between variance. Now, the calculation of within variance, we take individual rows. We take individually, we take y1, then we do y1 minus y1 bar, then we do y1 minus y1 bar, the whole square of it, then we do the summation of it. So this term is summation y1 minus y1 bar whole square. Same thing we do over here, we do the calculation for y2 minus y2 bar, and this is y2 minus y2 bar, the whole square of it, and this is here summation y2 minus y2 bar, the whole square of it. Similarly for y3, this is series is this last term which we got over here is summation y3 minus y3 bar, the whole square of it. So it is 1000, 1000, 1000. So here we write 1000 divided by total values 15, and how many classifications, how many groups, 3. So to 15 minus 3, that is equal to 12. So 3000 divided by 12, that is equal to 2250. So this is calculation of within variance. Now, what is F statistics? Between variance divided by within variance. The formulas for between variance, the formula for within variance. So F calculated value, we get it equal to 50. Then we will compare this with the table value, and we will be accordingly accepting or rejecting the null hypothesis. The same thing we can do it with the help of an Excel sheet. Every one of us on our laptops and computers, we have MS Office normally, and we have an Excel sheet over there. If you open up your Excel sheet, you will get an option of data, and along in data you will get an analysis of we will get an option of data analysis. But if you are if you are doing it for the first time, this particular thing, then you will not get this option. So the process is very simple. You simply go to file, then you go to more, you will get this options. In this options, you will get an option of add-in. In this add-in, when you click OK, you will get a dialog box. In your system, when you are doing it for the first time, this analysis tool pack will not be checked like this. This will not be there. It will be just like the one like these. You simply have to click it, check mark it, and then click on OK. The moment you do, now once you go for data, your data analysis will come, and when you click on this data analysis, a dialog box will come like this. There are many things which you can do over here. Means you can do descriptive statistics, you can do analysis of variance, you can do different type of t-test, you can do different types of ANOVA also, like with replication, without replication. You can do correlation, regression, moving average, exponential smoothing. There are many things which normally of statistical of nature, they you will find it over there. So then this dialog box will be asking you, you have to select all the data, you have to tell the computer that the data is arranged in columns, and since in the first column, in the first item is x1, x2, that is not a number, rather it's a label. So you have to tell the computer that this is there are labels, in the first row is consists of labels. Then you give, it is normally at 0.05, if you can change it also, but normally in economics and business and commerce we do it at 5% level of significance. Then it will ask where do you want the result. You tell either either on a new sheet or on a particular place on the sheet. You select it by, I said give it to me in row E1. An answer would come like this. This is they are giving you what is the sum of the series, they are giving the average, and they are giving the variance which we have computed in the earlier case. So sum, average, variance, it is calculated. Then they have done the calculation. See, this is your total variation. So these two add up to your total variation. Similarly, you have your mean squares. So you got, this is the value which you have also got, 12,500 and 250. 12,500 and 250. If you just go back between variance, 250 within variance. So these are the same terms over here. These are the same terms over there. And when you are doing, you get the F value, that is 50. We also got 50. The beauty of Excel sheets and all, or using a software, is you don't have to refer to this table. You don't have to go and refer to what is the table value. They are giving you the critical value. That is, this point is 3.885294. They are giving you this point, and also they are giving a p-value. So you can compare this 50, 50 will be somewhere over here. It will be more than 3.88. It means the null hypothesis is rejected in this case. And we can also do it by p-value. This is, it is written as 1.5129 e minus 6. This e minus 6, because the space in the Excel sheet is small, so it is this, it basically means if I want to interpret this value 1.51279 e minus 0.6, it means after decimal point there will be 1, 2, 3, 4, 5, and then from the sixth term it will start. This is basically this number. So this, the criteria is 0.05. If this p-value is more than this, then it is not significant. If it is less than this, then it is significant. Now, if you wish to compare, this was what is this SS between groups? This is this, and how it has been calculated by using this formula. Within group, sum of squares, this has been calculated by this formula. The total has been calculated by this formula. The degrees of freedom, there were 3, so 3 minus 2, this is 3 minus 1, that is equal to 2. Within group, it was 15. There were 15 items and there were 3 groups. So n minus k, that is 15 minus 3. So you get 12. And for the total, n minus 1, total 15 items. So n minus 1, 15 minus 1, 14. Then we use the mean square. So what you have? You simply this number, this is this number divided by k minus 1. So the same number, 2500, then we get this 12,500. We use this formula, we get this 250. Then what is F? F statistics is this value divided by this value. So f statistics, the formula is written, and we will check it with the table value. So f statistics is equal to 50. So this is basically how you can, the result which is given in Excel sheet, how you can take it from here. With this, with this we this lecture comes to an end. In our coming classes, we will continue with our further discussions on analysis of variance. Thank you.